So the slope of a position time graph is velocity. That is a positive constant velocity. If you were drawing the velocity time graph, be that. Or Sage, you could draw it lower, because I didn't put any numbers. I really don't know how steep it is. Or you could draw it higher, but what I would be looking for would be a horizontal line. That's a constant velocity, because on a velocity time graph, velocity is your height. How high are you? Same height, same height, same height, same height, same height, same height, same velocity, same velocity, same velocity, same velocity, same velocity. What would the slope, B. What's this here? What's the slope of this line here? What? 0. What's the velocity then? 0. What would that look like? That. Because how high, remember, on a velocity time graph, velocity is your height. Julie, you're with me? Oh, yeah, sorry. I thought you were looking at your phone. Never mind. You were writing. My bad. I falsely accused you. Whenever I see kids screening with the binder, I always get suspicious, right? It's okay. These two are physics 11E. What do you notice about the slope, the steepness of this line? Increasing. I'm going to ask you the same question. I'm going to phrase it different. I want the same answer, though. What do you notice about the velocity of this? It's increasing. There. You could draw it shallower. You could draw it higher. But you know what? I'm telling you, you're speeding up. Your velocity is increasing. By the way, what's the acceleration of this graph? This is a velocity time graph. Where does acceleration appear on a velocity time graph? It was the key idea that I started out class with. Jessica repeated it a couple of times for us. Where does acceleration appear on a velocity time graph? I know it's acceleration. Where does acceleration appear? Yeah, slope. What's the slope of this? Constant speed. What's the slope of this? Constant speed. In fact, your constant speed is 0, which is technically a constant speed. What's the slope of this? Positive. You're speeding up. I can't say more than that without actual numbers. What can you tell me about this steepness here? Decreasing. Slowing down. Slowing down. Then I also gave you this bad boy here, sketching velocity versus time graphs. Okay? Now, if you haven't done this, I'm going to put this answer key online. Don't just copy, but if you haven't done this, so I'm going to do an answer key. If you haven't done this, don't copy this. Try this on your own and then check your answers. So here's good old answer key. It says, sketch the following. The object is moving away from the origin at a steady speed. Does it say forwards or backwards in this question? It says backwards in number 1? Away. Okay. If you said that means backwards, I would accept that. To me, that's a vague word. I'm not a big... I like the notion of getting you to sketch graphs, but I stole this from the internet in case... And I would have made this a bit more formal. Yeah.
I'm running away from something forward.
See, that's the other... If you're running away... It depends whether you're thinking about whether you're standing at the origin or whether you're imagining that you're the object. Okay? Anyways, here's the key idea. What does a steady speed look like on a velocity time graph? This or that? Horizontal. So either that, or if you decided that you were moving backwards, I would accept that too. I'd give you full marks for either because this question isn't worded carefully. What I would take marks off for is for slanty. Here's the other way you can think about it. Ready? What's the slope of a velocity time graph? Tell us. Begins with letter A. If you're at a steady speed, what's your acceleration? What's the slope? See, all comes together. I'm better at the math with the formulas, but I know some kids are more visual and they like the graphs. And there's room for both. And on the provincial and on your test, there will be both. The object is standing still. This one, all of our graphs would look alike. If you're standing still, what's your velocity? 0. What about after 1 second? What's your velocity? Still. What about after 5? You know what? No matter what time it is, you're 0 high. And your acceleration is also 0. The object moves towards the origin. Okay, I think now it's coming backwards towards us. Then stands still for 10 seconds. I would look for something like this. Oh, at a constant speed. Can't be slanty, Mr. Dueck. Moves towards the origin for 10 seconds. And then what does it do for the next 10 seconds? Now, I'm not going to give you questions quite like this with this little information on your test. On your test, I'll give you numbers. Can you make it, Joseph?
Yeah.
Okay. Object moves away, I'm going to say forward at a steady speed for 10 seconds, reverses direction, there's my backwards, and moves back to the origin at a steady speed. So here's 10 seconds. That, look up, I'm going to make a mistake, see if you can tell me why this would be wrong. Is my velocity negative? Is my velocity below the x-axis? Is it in the, so that is backwards. What words did I underline? So if I was being really fussy, whatever height you drew this line at, that's the same height below the x-axis, because where does velocity or speed appear? The height on a velocity time graph. Turn the page. This is more similar to what you're going to get on the test because this has actual numbers. This has actual numbers. So it says, draw velocity versus time graphs for an object whose motion produces the position. Okay, position versus time. What does the slope tell us for a position versus time? For velocity versus time, slope tells us acceleration. For position versus time, slope tells us velocity. Can you go rise over run? This one's actually really nice because what's the rise? Well, you can go 1 over, first of all, what's the rise? 4. What's the run? 4. 4 over 4 is? I would look for a graph exactly like that. And this, I would be fussy on your height because I gave you numbers. There's a change in velocity right there. So for the first second, how fast are we traveling? What's the rise? What's the run? So what's my velocity for the first second? Yoink. Then, how fast am I traveling for the remainder? For this line, what's the rise? Careful, don't say 4. I know the final height is 4, but it doesn't start at 0. What's the rise? 2. What's the run? Okay, so this has a slope of, right? Or in lowest terms, or as a decimal, I'd be looking for a line, right there, but I wouldn't let you draw it in there. Don't start at 0. Last one. For the first 2 seconds, how fast are we traveling? What's our slope here? 2 up, and how far over? So, the slope here is 2 over 2. 1 over, so the velocity for the first 2 seconds is what, Taylor? Positive. What can you tell me about the velocity for this section? Positive or negative? Negative, so I'm going to be drawing down here somewhere. Is that okay, Allison? And by the way, the reason this is tough, there is lots of room to make sloppy, easy mistakes, like missing the negative, like counting the slope wrong. Like, don't kid yourself. This is tough. So if you're finding this tough, congratulations, you're normal. What's the rise? 4? Brooke, what's the run? Count with me. 1. So this is negative 4 over 2, which in lowest terms is negative what? What's your velocity? Negative 2. Okay? So before class is over, hand that in. If you did it, you can do corrections. If you haven't done it, you can try it. But today we are working on, count them, 2 things. And you'll have all class because I'm, okay? So here's your sheet on acceleration. Here's what you're going to do. This is, again, similar to some of the questions you're going to see on the test. Those of you that just got here, I've said, I'm done the unit. Right now, I'm looking at your test being not this Monday, but the following Monday. We're going to do a couple of days of review, putting everything together. Did I miss you guys?
No, it's not.
Yep.
How many chapters do we have?
We got to do 1 chapter on plate tectonics. I'm hoping to get that done in about 2 weeks. And then we got to do a whole section on the environment and life sciences, and I'm not going to finish that, but I will put my videos online, and it's fairly read the textbook common sense-ish. It may come down to, in those few days that you have before school is ended, after school is ended, but before your provincial, I'm going to say, here's the videos, watch it. And the decision I made at the beginning of the year, I could either go crazy fast and try and cram it down your throat and lose most of you, or I could cover the material that I'll get through well so that you can do well on those sections of the provincial. There's going to be some questions on the provincial where you're going to have to read the textbook or guess. Sorry.
So wait, is this the rest we have done letter for physics?
Yeah. Okay, can I continue now? Good, shut up. Folks, as I was saying, if you look, here is an idea of some of the questions that you might be asked to deal with for velocity versus time graphs. So you should be able to find the acceleration. Hey, where does acceleration appear on a velocity time graph? Slope. Then I'm making it a little bit more difficult when you get to number 3. Once you calculate the acceleration, you will know A. Look at the graph. What's VI? Yeah, what is it from the graph? Read it.
6.
What's V final? 3. So now you can, from the graph, for where it says find t, you can find time by using VI, VF, and you just found A from the graph. So now we're putting it all together, both the equations from 2 lessons ago and the graphs from last lesson. Now you can start to use them, I won't say interchangeably, but to complement each other. And then 5, 6, 7, 8, 9, the following, a lot of these are going to be DFIC questions. See if you can figure them out. Now, can you all look at number 12, please? Can you all find number 12? Ty, this is totally fair game, because what's it asking you to find in number 12? Acceleration, okay? Now, there is another equation, which I wish we did in Science 10, because if we did that, then I could open up a whole bunch of other cool questions. For example, we could figure out how far you fall during free fall, and it's this. D, what do you think D stands for? What do you think VI stands for? What does T stand for? When I write 2 letters side by side, mathematically, what does that mean? Add, subtract? Okay. Plus, what do you think a half stands for? What will you type on your calculator? 0.5? What does A stand for? What does T stand for? Oh, squared. What does a squared mean? What's 3 squared? 9. Okay, and most of you, if you have a scientific calculator, you'll have an x squared button on your calculator. Otherwise, you'll just have to go times by itself. Okay? Oh, hang on, we got an interruption. Let me pause the video here. No problem.
Just thought you might need a piece of meat.
You can use this equation to find the challenge question, how far. I will not be asking you that on a test. I just need to make sure you're clear on that. That's actually Physics 11. Again, I wanted to do something useful. Here's a runway question. You can certainly do part A, find how much time it takes to reach takeoff speed. But a more interesting question for an engineer would be, how long do we have to build the runway? How length? And you can calculate that using this equation that will, again, Allison, let me emphasize, not be on the provincial. So that's assignment number 1. You can probably get this done in class pretty easily. And then I have for you a practice test. This has got a little bit of everything. The answers, did I attach the answers? I don't think I did. Maybe I did? Wow, that was nice of me. I did. Double check, make sure your answer has a typo fixed on number 9. Can you double check for me? Is number 9 crossed out? It's not D, it's A? Okay. But there's lots of mistakes in the answer keys in this unit because whoever put it together really didn't know it. Anyways, that's your second assignment, and that'll be due. When do I see you guys next? Monday. On Monday, we're going to be doing some review. I'll also probably have a take-home quiz. Wednesday, we'll probably start the next unit. It's on earth science. It's on geography. It's kind of cool. And we're going into a very different section of the course. The remainder of the course after today is not going to be understanding and math like chemistry and physics. It's going to be memorizing stuff, which some of you like, more like along the lines of biology and earth science. It's up to you. Any questions what we're working on today? The acceleration sheet, and then the practice test. If you get that done in class, you're fine.